the formula. From this balanced equation, we find out that the ratio, mole ratio is what? 1:1. Okay, I've already written that there. So the volume of the concentration of A is now 0.10. Volume of A is also 29.4 as given. We have 29.4 here, cm cube. Then multiply concentration. This is the mole per dm cube of this. Of the B, we don't know it, but we know the volume, which is 25. The volume is 25. Then their mole ratio is 1:1. So if you cross multiply this, we'll have 25 Cb equal to 0.102 times 29.4. Then Cb will then be 0.102 times 29.4 all over 25. So what are we going to get there? What we are going to get will be 0.119 mole per dm cube. That's what we have. We're able to get this. The next one I'm going to do now, this is another interesting part of it. Yeah, we have a question here. It said A is a solution of trioxonitrate acid containing 1.6 gram of the acid in 250 cm cube. B contains 10 gram of S hydrogen triazocarbonate in 1 dm cube of solution. Then the next thing said that 25 cm cube portion of B requires an average of 29.4 cm cube of A for complete neutralization. Then the main meat of this question says that we should calculate the concentration of A in mole per dm cube, concentration of B in mole per dm cube, molar mass of S hydrogen triazocarbonate, and then we find the value of X. That's the last question. We have the equation of reaction and relative atomic masses of all the elements given to us. So what are we going to do here? Based on what the information given to us, note, we said that we can calculate the concentration of A in mole per dm cube. And what we are given here is gram of A that is contained in the solution. That's contained in the solution, and then the volume of the solution where we dissolve was 1.6 gram of the acid. So now, if you are joining us for the first time, we want to encourage you to subscribe, like, and share. And then if you have any question, also leave it in the comment section. But then I want to encourage you, if you are preparing for any exam that has to do with chemistry or WAEC, JAM, or related exams, I encourage you to watch the end. There's a lot you're going to learn from this. Don't just keep it. Thank you so much. Let's continue. So now you said you calculate the concentration of A in mole per dm cube. Now what we have here is what? 1.6 gram. In order to get this, what are we going to do? First, look at what we have there. To solve that problem, the first problem there, you notice that the first thing you do here is to get this volume in dm cube. That's one of the ways. And then you get the mass that is contained in also 1 dm cube. So now let's quickly do it. It means that from the statement we have here, starting from what we have, we said that 250 cm cube of the acid has 1.6 grams. So what is the 1000 likely to be? 1000, which is, we know that 1000 cm cube is equivalent to what? Is equal to what? 1 dm cube or 1 liter. So now what are we going to have here? Means that 1.6 times 2 plus 250 times 1000 over 1. So when we divide through, what we're going to likely to get there is 6.4 grams. So that is what we have in 1 dm cube, because we always work with dm cube. That's what we have. That is 6.4 gram per dm cube. That's exactly what it's supposed to be. So now, but that's not the end of the game. That's not the end of the game, because we have, they said, in mole per dm cube. Mole per dm cube. That means if you are going to do it in mole per dm cube, what we're going to do here is that we know that we need to find the relative, we need to find the molar mass of this, the molar mass of that. So we need to get the molar mass. Then what are we going to do there? We know that nitric acid contain hydrogen, nitrogen, and oxygen. So from what we have here, hydrogen is 1, nitrogen is 14, and then oxygen we have is 3. That means 3 times 16. So what do we do? When we add up everything we have here, this will give us, I think it should be 48. It should be 48. 3 times 16 will give us 48, yes. Then we have plus 14 plus 1. When we add up all these things we have, plus 14 plus 1, we have, what we have is 63 gram per mole. So that's what we have. And we know that 1 mole is always equal to the molar mass. So in that case, what are we going to do here? What we're going to do here is that, since we know that um 63 gram, okay, 6 grams of the acid is equal to what? 1 mole. Then 6.4 gram will then be equal to 1 over 63 times 6.4 over 1. So what we will have to give us 6.4 divided by this, we have 0.102 mole per dm cube. That's what we have. That means we're able to solve this first one. We've solved the first one. So the next one we're going to be doing now is concentration of B in mole per dm cube. So what we're going to do, I think we can just keep this here. We have a 0.1 per dm cube. That's for the acid. So let's just keep it here while we do the cleaning. All right. The next thing we are going to do now, since we have we're able to get the A, then what we are going to do now is to calculate the B. So now, for us to solve the B, we need this formula. We need the formula. From this balanced equation, we find out that the mole ratio is what? 1:1. Okay, I've already written that there. So the volume of the concentration of A is now 0.10. Volume of A is also 29.4 as given. We have 29.4 here, dm cube. Then multiply concentration. This is the mole per dm cube of this. Of the B, we don't know it, but we know the volume, which is 25. The volume is 25. Then their mole ratio is 1:1. So if you cross multiply this, we'll have 25 Cb equal to 0.102 times 29.4. Then Cb will then be 0.102 times 29.4 all over 25. So what are we going to get there? What we are going to get will be 0.119 mole per dm cube. That's what we have. We're able to get this. The next one I'm going to do now, this is another interesting part of it. The say that the molar mass, this is the major area in this calculation. We are going to be calculating the molar mass of what? Of S hydrogen triisocarbonate. To do that, what we need here will be, what we're needing now, what we're going to work with will be 0.119 mole per dm cube. So what are we going to do next? This molar mass, to solve the molar mass, we all know, as we have already stated before, we know that 1 mole of any substance equals the what? Molar mass. Then the 1 mole of S hydrogen triisocarbonate will then be 1 mole of that compound. Okay, let's start from what they're giving, they know. That means 0.119 mole of the S hydrogen triisocarbonate is equal to what? 10 grams. 10 grams we are giving. Also given to us 10 grams. So that is what it means. In this solution that contains 1 dm of the S hydrogen triisocarbonate, will have 10 grams of it. So it means that this 0.119 is equal to 10 grams. So what are we going to have? What are we going to have if we are looking for the mole? 1 mole now, 1 mole, which is always equal to the molar mass. 1 mole will then be equal to 10 over 0.119 times 1 over 1. So when we do this, let's see what we are going to get. It will then be 10 divided by 0.119. So what we have is 84 gram per mole. That's what we have. That means we've been able to get what the molar mass of the acid. This is very, very important. If you want to do this by titration, whenever you're titrating, it's important to get to know this relationship, which is very common. That is a mole. A mole is always equal to what? Molar mass, and also the other one, we have molar volume and the case may be. All these things are very, very important. Molar volume, which is 22.4 dm cube, and the other related like Avogadro's. All these things are important if you are really dealing with chemistry calculation. Then if you understand the way the way to apply them, it helps you so much. So this now, from here we've been able to get this. The last question we have here said that we should calculate the value of x. In getting the value of x, what are we going to do? Now we know that X hydrogen triisocarbonate, this is the formula for that. That's the formula. Now what do we have inside here? And we know that this formula, now everything we have here will be equal to the molar mass, which is, now we'll be able to get it to between 84. If it's 84, then we know that all of them, in calculating the molar mass of every substance, we add up their relative masses. So in calculating that, what we do here, we don't know the X, but we know H to be what? 1. That's hydrogen. And also plus C, which we know to be what? 12. And then plus oxygen, which we know from this place is 3. That means 3 times 16. So what do we have here? 48. Also we have 12 plus 1 plus X. If we were to add up these things, if we're adding it up now, if we add up this, we will have something that will be S plus 61 equal to, let me just confirm what I have here. Okay, it's correct, 61. 61. So to get the value of S, we simply means 84 minus 61. That means S is likely to be, that is 203. Yeah, that's what we have. That is S. The value of S is what? 23. 84 minus 61 is 23. So that's the last and the last question that we have here. Thank you so much for being part of the class, and then we want to encourage you to subscribe and like and share so that this very solution will get to the people, other people that need it, so that they will also enjoy with us. And thank you so much once again.